We are going to balance this redox reaction moving through the process one step at a time. If you follow a step-by-step process, you will have good luck with balancing equations. You'll first notice that this equation cannot be balanced by inspection. Balancing by inspection is the traditional way of balancing the atoms on the reactants with the atoms on the product side. But you'll see I've got some oxygen here that isn't showing up on this side. I have charges here, which isn't traditional in a regular balanced equation. We can also see that we have an oxidation reaction by writing the oxidation states for all of the atoms in the equation and see who is reduced and who is oxidized. So the first thing, the oxidation state of Fe, when it says it's +2, it is +2, so I've written +2. The oxidation states of an MnO4 -2, the O4 has to be done this way. The rule is the O is worth 2, and there are 4 of them, so that makes this piece a -8, and the whole thing is equal to -1, so it's what number -8 equals a -1, and the answer to that is a 7. So +7 is what the Mn is. It's the answer to my mystery box. So the next oxidation number is told to you right there. If it tells you what it is, that's what it is. And likewise on the manganese. So those are my oxidation states. Now, how do you know who's reduced and who's oxidized? Well, you're going from a +2 to a +3. To do that, you have to be losing an electron. Losing an electron is oxidized. If you're going from a +7 and now you're at a +2, how did that happen to you if you only could be dealing with electrons? That means you gained 5 electrons. Gaining electrons is reduced. So we say, Leo says grr to memorize that. The next step is to write the half reactions, meaning split it in the 2 pieces that you see for the halves. So here is the center of my reaction, and the question is, what is Fe +2 becoming over here? It's becoming Fe +3. So I write Fe +2 yields Fe +3. And that leaves the MnO4 -1 to become the Mn +2. So that's the other half reaction. So I've divided it into 2 half reactions. The next step is to balance everything except for hydrogens and oxygens. So that means the other elements. So I have 1 Fe, I've got 1 Fe. Check, that's balanced. I have 1 Mn, I have 1 Mn. Check, that's balanced. The next step is to balance the oxygens. And you balance oxygens by adding water. The reaction is happening in an aqueous solution, so 1 more water molecule won't be noticed in this reaction, so we're going to add water to balance this reaction. So nothing is needed over here. The only one that needs to have some more oxygens is this side. I've got 4 oxygens. How do you get 4 oxygens? You add 4 waters. So that's how I get 4 oxygens. So I've added 4 waters to the side that does not have oxygens. Now I have to balance the hydrogens. I do that by adding an H +1. And it's really important that you put that +1 because charges matter in a redox reaction. So there was no need on the iron side. But on the side that we just added water to, we now have altered it by adding 8 H's. So that's why on this side I add 8 H plus 1s. The next step is that the charges on the reactant side must equal the charges on the product side. So you're going to be counting up the charges, and whichever side is greater, you're going to be adding electrons to that, and that is how you're going to balance out the charges. So let's look at our Fe side. I had a +2 on this Fe, on the whole side, +2. And on this side, I had a +3. So how do I knock down the +3? I add an electron. And by adding one electron, now this side over here is also just +2, and they're balanced. So before I added these 5 electrons, I had 8 pluses, so I have a +8, and I have a -1. That's what that just plain old minus by itself is. So this side used to be a +7. On this side, I have a +2, and I have a compound that's neutral, so that's 0. So this whole side is a +2. And so how do I do it? I knock this side down. How? By adding 5 electrons. If I add 5 electrons to this side, that's 5 minuses, that makes this whole side over here now +2. And they're balanced, +2 and +2. So now the electrons have to be balanced because they have to cancel out of my equation. So I have 5 on this side, and I have 1 on this side. So the least common multiple of those two things is I need to get this side to be 5. So multiply everything in your equation on this side times 5. That will get my electrons to be the same number to cancel out. So 5 goes in front of here, goes in front of here, and goes in front of here. So that's how I get 5 Fe plus 2 yields 5 Fe plus 3 minus 5 electrons. Now my electrons can cancel out, and they have to be on opposing sides. So you see these are products, and these are reactants. That's good. The only way this problem will work is if they're on opposite sides. So they've canceled out. And then I'm going to add the reactions together. So I've got 5 Fe plus 2, and that gets me to the arrow, and then I come over here and pick up everything over here that's a reactant and put it in my equation. And then I take everything that was a product, 5 Fe plus 3, that's right here, and my Mn plus 2 and 4 water. So my reactants yields my products. So when I'm finished, I should have everything the same on both sides. So double check. I got 5 Fes, I got 5 Fes. I've got 8 H's, I've got 4 times 2, so that's 8 H's. I've got 1 Mn, I've got 1 Mn. I've got 4 O's, I've got 4 times 1, 4 O's. You also have to check the charges. So let's look at the charges. So I have 5 things that are plus 2. That's a plus 10. I've got 8 things that are plus 1. That's a plus 8. And I've got 1 thing that is a minus 1. So this whole side of the reaction is a plus 17. On this side, I have 1 thing that's a plus 2. I have 4 things that don't have any charge. And I have 5 things that have a plus 3. That's a plus 15. So plus 2 and plus 15, that's a plus 17. If your reaction is in an acidic solution, which you see these 8 plus H's, H pluses. That lets me know it's acidic. That's our indicator for an acid, is having hydrogen ions in the solution. So if you are doing it in acidic solution, you are now completed. If you are doing this in a basic solution, you will have to do 2 more steps. All right? Have a good day.